Good morning, fellow algebros. Today we're going to be learning about Cramer's rule. And Cramer's rule is how we're going to solve systems of equations using matrices. Oh yeah, super exciting. So remember, back to your Algebra 1 days, a system of equations is two equations that cross at some point, or sometimes never cross, or end up being the same line. So when we are solving systems of equations, we want to find the x value and the y value that are solutions to both equations. So essentially, visually, we want to find where those lines are going to cross. So there's a few things I want you to notice as I hope you're writing down. This is the general rule for Cramer's rule. So as you're writing that down, I want you to notice a few things. My equations are written in standard form. So not y equals mx plus b or anything other than that. So they're written in standard form. So again, our goal for solving a system of equations is to find an x value and a y value that is a solution to both equations. So when we're finding our, so we're going to find determinants of our coefficients to find these solutions. So another thing I want you to notice is that the denominator, or what we're dividing by, is the same for both. And you're like, well, Ms. Bauer, where did these random letters come from? Well, these random letters come from our two equations over here. And it's A, B, D, E. Those are the coefficients of the x and the y values, or x and the y variables. Sorry. Whew. There's something in the air today. Probably should have taken some allergy medicine. That's all right. All right, so it's the same for both of them in the bottom, but in the top, it's a little bit different. So notice that we have B and E, which are the coefficients of the y values, but we don't have the coefficients of the x's. We have C and F to replace A and D. So when we're finding the x value, we don't want the x coefficients in our determinant. Same with our other one. Here you can see we have AD, which is the coefficients of our x's, and we're finding y. So to replace the y coefficients, we have the solution to our two equations over there. So essentially, you could write the A, B, D, E 4 times, and then replace the x's with the solutions and replace the y's with the solutions. So let me show you what that would look like. Oops, that needs to be a y. There we go. All right. Well, we don't want to leave it like this, but this would be kind of a good formula to see what's going on. So since we're finding x, why is that so small? Whatever. Okay. So scratch the highlighter. All right. So since we're finding x, we want to remove the x coefficients here. Okay. because we don't want the x's in there. So what we're going to replace them with is the solution to the equation. So instead of A and D, we want to replace them with the values of C and F. All right, and same with the y. Since we're finding y, we want to replace the y coefficients, so B and E, with the solutions to the equation. So we want to replace B and E with C and F. And order does matter, because when you're finding that determinant, you're going to end up subtracting those values. So yes, order does matter. Okay. So this is just the general formula, and my next video will actually go over some examples. So see you then.